plus 2. There is plus 2. Okay, both of you, am I audible to both of you?
Yes.
So I'm going to show first rhodonium. Ruthenium. Okay. So ruthenium is just below iron. You know the configuration of iron. Iron is basically argon 4s2 3d6. This is the configuration of iron. Okay. Now what I need to do, it's very simple. So it is just below this. So ruthenium will have configuration argon. Can I write 4s2 here? So it becomes 5s2 and 5d6. Yes or no? Not argon, basically krypton it will be. Not argon, krypton it will be. Okay. And since we are talking about plus 2, so 2 electrons from this will be eliminated, and here it becomes krypton 4d6. Since with 4s, if you are taking 3d, so with 5s, what it will be 4d6, yes or no? Sometimes when I made mistakes, you are here to correct as well. Okay, you can tell me. Silly mistakes, these are sometimes it happened. Okay, so Austin and Humam.
Yes.
So this is your 4D series, and as I told you, this is your 4D series. Now, if you are going to do the configuration 1, 2, 3, 4, here what will be 1, 2, 3, 4, 5, 6. Now you know that 5s will also be there and 5p will also be there. 5p will also be there. What I told you, this 4D and 5D series, when makes a complex, the ligand will form a strong field ligand. The ligand will act as a strong field ligand. So what will happen? The pairing will take place. So if pairing will take place, what is going to be happen? This becomes already paired electron, and this becomes paired electron. This becomes paired electron, and 2 orbital is empty. Now here is your 5s, which is having 1 orbital, and 5p, which is having 3 orbital. If 5s is there, 5p will also be available. Now H2 will come into play. H2 will go in this and this, and H2 will make bond up to this. Since 6 H2 we have, so up to this, water will make bond. Now you can see what will happen. First we use D, so it will be D2 because we used two orbitals of D2 and sp3. So according to this will be octahedral. This will be octahedral. Octahedral. Is that clear?
Yes.
And it will be diamagnetic. All electrons are paired. If you are going to calculate mu, it will be equal to 0, isn't it? In the same way, you can go for osmium. Please do write it, Humam. What did you say?
Yeah, man, I don't know.
Now you can see we have another one, that is your osmium. So if you're going for osmium, now can you do the osmium part, yes or no? Osmium H2O whole 6 raised to the power plus 2. Osmium is just below ruthenium. So osmium will have configuration. You can see it will be basically in the last cell. It will the previous one was 5s2 4d6, so it will be 6s2 5d6 5d6. Now if you're going for OS plus 2, what will be the scenario? You can see it will be 5d6. Now again 5d6 and 6s0 it becomes. Again, you have to do the same thing. And again, this is your 5D series. So pairing will take place, and hence the hybridization will be D2sp3, and hence the uh, it will be octahedral. There will be no paired electron, so it becomes diamagnetic, and then mu will be equal to 0. Is that clear, Humam?
Yes, sir.
Now, can I change the slide? Humam, can I change the slide?
Yes, sir.
Very good. So the next one that we are going to talk about, this I gave you in the homework, which is very important. So yeah, also give you for coordination number 4, we were doing this. Okay, not a problem. Both of you are going to answer me for this one. Uh, NiCO, this is a very special kind of problem, carbonyl compound. What was the hybridization that you got? Austin, Humam, sp3. Austin, what about you?
SP3.
sp3. So basically, how did you get sp3? I wanted to know. If you are going to do the configuration of nickel, you know that this will have oxidation state 0. So simply you are going to do argon 4s2, 3d8 or 7. Tell me. Cobalt is 27, then nickel, copper, right? 28.
Yes,
Now, when you are going to do the configuration, write the orbital. D has 5 orbital. 1, 2, 3, 4, 5. So 8 electron is there. So 1, 2, 3, 4, 5, 6, 7, 8. And then comes your 4s2 as it is. So you have 4s2. And then 4p is also there because 4s is possible, then 4p is also there. So how did you say its hybridization is? sp3. S is completely fulfilled. What happened? Why did you say it is sp3? Austin and Humam. See what happens since CO is a strong field ligand, what I told you, it is a strong field ligand. So this will be excited in this part. So you know what will happen? 1, 2, 3, 4. Okay. Now you also know that this is your two electron paired, and this is also your paired. This is already paired. This becomes paired. This becomes paired. And this CO is pi acid ligand, very strong ligand. So it will, this S electron will be transferred to this, excite like this. Okay. Now what will happen? Very simple. Now 4s is empty and P is also empty. P is also empty. 4p is 0, 4p is 0, and 4s is also 0. Now what will happen? This CO will come and bond with S in S orbital, then 3p orbital. So you can see it will be sp3. Is that clear, both of you?
yes,
And there is no unpaired electron, so diamagnetic. Also, when you are having this hybridization, the geometry will be tetrahedral. Diamagnetic, so mu will be equal to 0. So both of you are done with this. Can you change the slide?
Yes.
Okay, moving to the next. NiCl4, tell me the answer for whatever I gave you. The answer, like what is the hybridization geometry? Tell me. Hybridization of this. This I gave you in homework, right? SP3, very good. What is about, what is its, what about the geometry? Hybridization is SP3. What about geometry? Very good. What about magnetic nature? What about mu, magnetic moment? Very good. So you did it correctly. Now moving to the next question I gave you. PdCl4. Tell me about this one. -2. And PtCl4. Tell me about this one. Each and everything. Right. Magnetic moment. Are you talking about this one? Magnetic moment.
Yeah, yes.
NiCl4. Okay, very good. Uh, Austin, you told me about this magnetic moment is zero. Is
Yes, I meant the other one before.
uh, what did you say?
I meant for the one before that.
Okay, okay. So tell me about this one, PdCl4. What is the hybridization? PdCl4 is not sp3 homam. As I told you in the lecture that when I explained, I think, let me show you. Yeah, here I was talking about tetrahedral weak field ligand and this. Then I gave you example this directly. Okay, okay. Yeah, here it is. Nickel. In 4D and 5D series, always pairing up. That means if weak field ligand will be there, it will convert itself into a strong field ligand. That means basically weak field ligand will also be acting as a strong field ligand in this case. Are you getting my point? In case of
Okay.
platinum and palladium. So here, this Cl4, which is a weak field ligand, becomes a strong, and hence the hybridization becomes DsP2 diamagnetic. Okay, and DsP2 has a geometry that is a square planar, and then mu will also equals to 0. In the same way, if you are going for PD platinum 45D series, again DsP2, each and everything will be simple, similar. Is that clear, both of you?
Yes.
Okay, I want answer. I got confused about this. Tell me the answer about this. What is the hybridization of this? Austin,
SP3.
SP3. Tell me the geometry.
Tetrahedral.
Tetrahedral. That's good. Tell me the magnetic nature.
Para.
Paramagnetic. Very good. Tell me the magnetic moment. Yeah, I couldn't hear you.
Sorry, calculate that.
What did you say? Uh, okay. Didn't calculate, sir. I did. Please do calculate it. Very important it is. Root 8. Very good. Very good. So you can say 2.75, or if you are going to be specific, it will be 2.82. Just wait a minute. Okay, only one topic and one more topic, which is a very simple and easy left. Before that, I would like to give some questions on this topic, which is very important. Have you got assignment on this topic, VBT? Because this topic is very important for this chapter. Yes or no? Have you got the assignment? Yes or no? Okay, did you complete that? Just tell me yes or no. Not yet, sir. Very bad. Did you complete every assignment of your every topic? I want to know about this. Where do you complete your assignment? Oh, mom, you are not responding at all. Do you complete your assignment? Yes or no? No, you. So you don't attempt the assignment at all, or you don't do, like sometimes you do and sometimes you don't do. Tell me honestly so that I'll be able to do something about this sometimes, sir. What is the problem for this? Like you are not getting enough time, or it is just your careless. You are careless about the assignment. Tell me, respond as soon as possible. I will complete, sir, after class. Okay, that is good thing, but till now, what is the problem that was stopping you to complete the assignment? Maybe it's like some questions are tough, or you're not able to understand. So generally, we lose interest in solving the questions when we face problem, or we when we get doubt. So if it's like that, so there might be a solution. So anything that you are facing, or anything that is stopping you to solve the assignment, just let me know. We will talk about this, and we'll do something about this. Austin, what's your problem? Tell me, both of you, your problem. I want to know. Mm, Other classes and exams. So see, exams will be always there till you for your class 12th preparation. These exams are for your class 12th main board exams. That matters. So if you are going to leave this assignment behind and preparing for a specific exams, so that topic will be lagging behind, and it will be a very big problem at the end. So you have only one thing to do, that is a study. So you have to manage it. If you're going to leave the topic, one topic today, and after 1 month it will be whole 2 3 chapters, and after chapters it will be a whole book. So how you will manage at the end? At least you should that's no, sir, I just forgot about it. I have term one examination coming, that's all. Forgot term one examination is coming, and the syllabus is See, term one exam and whatever exam is coming, that is not going to be counted in your upcoming life. For the whole life, you are going to show your class 12th board exams paper result, and then sometimes, I mean to say that uh, if you're going after class 12th in any college, at that time this class 12th result is very important. So try to manage this. In assignment there are not much questions, like 4 to 5 questions. You cannot make excuses, right? Mom and Austin, how many questions do
Yes.
you have in assignment? 4 to 5 questions. How much time it will take? 4 to 5 questions. How much time it will take? 10 minutes, 15 minutes, 20 minutes, 30 minutes. Can't you give your 30 minutes? We have only 2 classes in a week. In 7 days, if you are going to give 1 hour to the two assignment, is it that much tough? So try to look at different things with different no what do, different what do we say? Just wait a minute. Mhm. Change your point of view and look at the things differently. If you are seeing that your exams is coming, that is good. You are going to prepare for that. But I think you can manage 1 or 2 hour for whole week, right? In a week, you can manage 1 or 2 hour for each subject. If you are having 3 or 4 different subjects, like main subject that you are dealing is physics, chemistry, maths, right? Austin. So what do you need to do? Only whatever we teach you, you just need to revise it. The questions that we do practice in class, you are going to revise that. And after that, what you need to do, just do 4 or 5 questions. And that will take maximum, if you have understood the concept 100% or 90% or 70%, you will be able to solve that question in 10, 15 minutes. Some of you will be easily solving, like very easy it is. MCQs, that is, most of the questions are. So in some assignment, it will take 5, 10 minutes. Some questions may be in physical chemistry or in this coordination compound, you have to give your uh, 30 minutes. Can't you give that? So please start studying. It's end of September. October is going to start. October, November, December, January, February. 5 months you have. Either you are going to be hero or zero. That depends upon you. You can easily do this. And please, whenever you are going to solve your assignment, please send that solution, whatever it is, whether it is MCQs or whether it is like you have to write the solution and all. You have to send that to the Learnivio admin. They will send me, and I will check it. Are you getting my point, Humam and Austin?
Yes.
Yes.
See, if the question is like straightforward, which of the following is correct or wrong, you are going to write the option A or B. You don't need to write the statement. Question number, that is important. Your name is important. Assignment and the topic that is determined, that is also important. You need to write that. Sometimes when I check your papers, I see there is no name. So please write the name as well. And if the question is like you need to solve that, so solve that on that paper. For numerical type questions, you are not going to write the option. You need to solve it. I need to see what you are thinking or how you are solving, and solve it like you are giving a board paper, class 12th board paper. Because I checked so many papers in which the students do directly. You won't get full marks if you are going to do directly. Are you getting my point, both of you?
Yes.
So please start doing these things. Very important it is, because this is your term exams, unit test and all. After December or in December, from December, you will be getting you will be having your pre-board exams. Then how will you manage? Either you can manage your board exams or pre-board exams. You will be like everything will be hodgepodge. There will be lots of pressure. So try to manage this from the coming month. And in 1 month, if you are going to make a routine like after every lecture, you should go through the whole chapter, like from first lecture from the beginning, introduction of the chapter. You just need to go through the chapter and the lecture that you study today, that you need to revise it in a good way, like write the questions, not write the question, write the solution. Do the solution again and again if you are stucking at any point, and do the assignment as well. Please do it.
Yes.
Okay. So let's start with this question. Today VBT I completed. Okay. So only one major topic left, that is CFT, crystal field theory. Okay. And one more thing I wanted to tell you is that if you are studying in any questions like in your test paper of Learnivio, in your assignment, what you should be active about this. Take a screenshot or write the question, or if you are getting any PDF file like that, you can take a screenshot and in class you should ask me, sir, I stuck in this question. What is the problem? Because both of you never asked any question from test paper assignment. I don't know. Maybe you are solving it 100% or maybe you are not solving at all. There is two probability. So if you will start asking question from test paper and assignment, then I'll be able to understand that whether you are solving it or not. So, and it's not that much tough to ask the question. You can share your question in the chat box easily. I can see that. I will copy that and paste it on the screen and we can easily discuss that. You have privileged of this that you are not using at all. So I'll recommend you to do these things in chemistry, in every subject. You can do this. Okay, now let's start this. Thank you. Isomerism for this chapter is very important. Let me know, is there any problem with this? How many geometrical isomers are possible in this? See, the question is very easy. I told you as this M, and this is a bidentate, so you can write AA whole thrice. Now this is your ligand AA. So can you make any AA? If you are going to pair it up, it will be AA, something like that. So these are same. When you are getting two same pair, it won't show any GI. So basically, for this type of molecule, no GI. Are you getting my point? Yes or no, both of you?
Yes.
Yes.
Now for this, I told you this is your Ma3B3. If you remember, Ma3B3. If you are going to make a pair, how you are going to make it? AA I can take, then I can take BB, and then I can take AB, something like this. Okay, then we can take AB, and then AB, like this. And then how you can take AB, and is there any possibility? So two different, so we can get two geometrical isomers in which you can see, I told you when this type of compound forms, you have two types of geometrical isomers. One is facial and another is meridional. Are you getting my point, both of you?
Yes.
Yes.
So you have to take care of this, and this is only possible when you are going to revise it again and again. Whenever you are going to start a new chapter, let's say today is our first lecture, so you are going to give your 100% to first lecture after the class. When you are going to have the second lecture, after second lecture, you will read the first, you will go through the second lecture first, and you can also do this, which will be very beneficial. You can just gently go through the first lecture and then second lecture. That is very important. Are you getting this? That will connect all the topics, and some topics in this inorganic compound, inorganic chapter, inorganic chemistry is very important, and which you need to learn, like how to make the pair, how, what is the criteria. Since if you don't know the criteria to classify the geometrical and optical isomers, if you don't remember the criteria, then how will you able to solve this? So that type of criteria you need to take in mind. You need to go through that on a daily basis. Okay.
Yes.
Is there any question or no? The next. So you will take your time, but solve it, and after solving it, not like in a hurry. You are going to solve it like if you are going to solve it in your board paper, and I will check this solution. So after class, you will send the pic or make a PDF and send it to the Learnivio admin. Do it. I'm waiting. Will you be able to answer this? Hybridization, geometry, nature, and magnetic moment. Discuss the nature of bonding in following. Yes, you have to calculate. See, whenever this type of question will come, it will be around for approximately 3 to 5 months, 3 years at least. So you need to calculate hybridization. You have to write it in an explanatory way, the way I explained it. Like write the configuration of ground state, then write the configuration of oxidation state of that element, then make that box orbital, then excite that, then write again the orbital and show the paired electron if there is possibility, then fill the vacant orbital and then write the hybridization, and then you are going to write the geometry, then magnetic nature, since it is paired, so diamagnetic, since it is unpaired, so paramagnetic, then write the magnetic moment. Please do it. Please do this. I'll be back in a minute. Yes. D2S is not the answer. Basically, this is your bidentate ligand. So one C2O4 will go in two orbital. Coordination number is 6 now. Since I haven't given any example for ambident to bidentate. So one C2O4, as you know that if this is your now let's say any orbital 3p orbital is there. If Cn is there, it will go in one. But if you have C2O4, you know that this will occupy two orbital. It makes two coordinate bonds. So singly it will go into. Are you getting my point, both of you?
Yes.
Now, can you solve it? If still you are facing any kind of doubt in this, you can ask me.
Yes.
Humam, are you solving it?
Yes, sir.
Okay, take your time. Uh, I wanted to know the ambition after class 12th. What's your plan? Humam and Austin, please do this question, then we will talk about this. weak field ligand. Who did this process? Mom, very good. All of this are done, right?
Yes.
Very good, very good. What about you, Austin?
Answer.
Very good, Austin. Did you also will send the of solution of this to the Nivio admin? Okay, Humam.
Okay, sir.
Okay, just let's start another topic that is your CFT, crystal field theory. Crystal field theory, also known as CFT. So what does this say? So very simple. We are going to learn about the theory. What does it say? What does it mean? Basically, the theory between CFT and VBT is a controversy. As in VBT, it was told that the bond is covalent, like coordinate bond. Coordinate bond is a covalent bond, sharing of electron, unequal sharing of electron takes place. Central metal atom will have vacant orbital, and then the ligand comes with pair of electron or negative charge, that means 2 electron. It will donate one of the electron to the central metal atom orbital. It should be vacant and then make bond. But according to crystal field theory, it is ionic bond. How it is basically? So I'm going to show you. I'm going to write some theories or point postulate type of this theory. So what it is, write with me. Ligands here are treated as point charge. Ligands here are treated as point charge, as you know that ligands will have lone pair or negative charge, so point charge. The B point is also very important. When ligands, first I'm going to write it, then I will explain. You can write with me. When ligands approach central metal atom, when ligands approach central metal atom, then they repel each other, then they repel, then they repel each other, and as both have electrons, as both have electrons. So very simple, as you know that central metal atom will have also electron and ligand have also electrons. So they when ligands approaches to make bond with central metal atom, they will repel each other. Now what will happen since it is charged, so electric field will be there. So in the electric field, of these negative charge, that means electron negative, these negative charges, the 5d orbitals, the 5d orbitals, the 5d orbitals, the 5d orbitals of the metal atom, no longer have exactly, just wait a minute please, have no longer exactly same energy. Just wait a minute please. Are you able to see the screen?
Yes.
Have exactly same energy. I'll explain this point first, write it. And the D part is the extent of the splitting of metal d orbital. How much it will split and how the splitting will take place. So metal d orbitals depend depend upon the nature of number of ligands. Nature of number of ligands surrounding it, surrounding it, and the charge on the central atom, on the central metal atom or ion. Please do write this, then we will discuss about this. Are you done with this?
Done, sir.
So CFT here is about to how the bonding takes place in complex compound come into play. And according to that, ligands are treated as point charge. When ligands approach central metal atom for bonding, they feel repulsion due to the presence of electron. Now, when the repulsion will take place, let's take an example. When the repulsion will take place, let's say this is your d orbital. Do you know each orbital has its name? Like S has only S, there is no, this is a spherical in shape, so no direction there is. But when you are going to talk about p orbital, it has three orbitals and known as px, py, pz. Do you know about this? Yes or no? You can name it px, py, z, any orbital, any box. What is the name of, since we have five orbitals for d, what is the name for this? Do you know? Yes or no? You have studied this in class 11th as well. Do you have any idea about this, Humam, Austin?
No, sir.
No,
Okay,
sir.
so like px, py, pz, we have this dxy, we have this dyz, we have this dxz, we have this dz square, we have this dx square minus y square, the name of the orbitals. This is on the basis of this orbital exists uh, in which axis. Okay, like you know that P has dumbbell shape. P has dumbbell shape. You know dumbbell, what dumbbell looks like. So this is the shape of dumbbell. Now if it is px, now let's say this is your x-axis, this is your y-axis, and this is your z-axis. So how it will be? So on px will be on x-axis, this is your px. Okay, now if you are going for py, so this will be your py, this will be your py. And if you are going for pz, so this will be your pz. Are you getting my point? This is your
Yes.
pz. So in the same way, D is what? D is double dumbbell. D is double dumbbell. That means one orbital will have two dumbbell. That is the shape of D orbital. Now come to the, this is about the shape. I will draw the structure or shape of the double dumbbell as well for the d orbitals, dxy, dyz, is and everything. But what does this postulate or the theory of CFT, crystal field theory, says? It says that when ligand is going to approach central metal atom, they will feel repulsion, and due to repulsion the d orbital is split. Now, since when the central atom is isolated alone here, these all orbitals, whether it is dxy, dyz, dxz, gz square, dx square minus dy, dx square minus dz square, this is your basically degenerate orbitals. That means they have equal energy. When they are not splitting, they didn't split, they have equal energy. But when central metal atom, when the ligand is approaching towards central metal atom, they will feel repulsion, and due to that repulsion, this d orbital will split. It will split into two parts. And this splitting of d orbital, since they split, so one of the part will have higher energy and one of the part will have lower energy. Are you getting my point? Let's say this is the, just wait a minute. Let's say this is the center where d orbital is there. 1, 2, 3, 4, 5. Now when ligand is approaching this, when ligand approaching takes place, what will happen? This will dissociate into two parts. This will be splitting into two parts. This is higher energy, this is lower energy. Initially it is equal energy. Now the splitting of this depends upon totally on the nature of the nature of the ligands. And you can see here I have written the extent of a splitting of metal d orbitals of the metal depend upon the nature of number of ligands or nature of ligands surrounding it and the charge on the central metal atom. Is that clear?
Yes.
Okay, now I'm going to show you. Now I'm going to show you right to topic. The splitting of or splitting in octahedral we are studying. Actually, we cannot complete this today. Uh, We will just draw the diagram and we'll continue in the next class. We can complete. As I told you, the splitting will be on the basis of how many number of ligand is surrounding the central metal atom and the charge on central metal atom. So since I have written octahedral, that means here the number of ligands or the coordination numbers simply we are talking about is 6, isn't it? Because 6 coordination number, either sp3d2 or either d2sp3, and it is octahedral, isn't it? Tell me.
Yes.
Now I'm going to draw. Oh, just wait a minute. Now I'm going to just draw this one. Okay, now see. You know that this is your y-axis. Let's say this is your x-axis and this is your z-axis. Now ligand can approach from anywhere for basically proper orientation should be there. So ligand can approach from z. Ligands can approach from this side and ligands is approaching from this side. Ligands from approaching from this side and ligand approaching from this side and ligand approaching from this side. Central metal atom is here. Now, when ligand will approach, will repulsion between the central metal atom ion and ligand and it will split. We will talk about a split, but first I'm going to draw the structure for this, all the orbitals of d orbitals. Okay, so first of all, I'm going to write this dxy. So for dxy, for dxy, this is your x, this is your y. For dxy, it's very simple. What you need to do, just draw in between x and y, and it will be your dxy. Are you getting my point? I'm not good at drawings, but you can understand, I think, easily, right?
Yes.
Now, the next one I'm going to draw is like this. Now you can see I'm going to draw dxy. After this, we can take dyz. Let's take this is z and this is y. So dyz will be in between y and z, between the axis. Okay, and please do write it. The rest two I will draw it. 3 I will draw it. Write all of this and then let me. Are you done with this? Okay,
Yes.
very good. So this is dxy dyz and then dxz. Dxz you understood that it will be uh, in between xz. So it will be something like this. You can see dxz. This is your x, and let's say this is your z. So this will be dxz. And for dx square minus y square, other two is a little different. Dx square minus y square will be on the axis. This is your dx square minus y square. This will be on the axis. All this dxy, dyz and dxz along the axis, between the axis, but this is on the axis, and the dz square is a special kind. You can see this will be on the axis. Basically, I will show you. Basically, this is your z, and this will be the dz square. This is dz square. Please do write.